All right, well, thanks for coming. I'm going to talk about what we all deal with every single day, which is complexity. So I've titled this as Don't Walk Away from Complexity, Run. Well, what I'm going to talk about today is mostly my own personal experience, journey through my efforts through my career as consultant. I worked with a lot of different companies, and I'm going to share with you some of the things I've noticed, observed, in terms of what I've seen organizations do and how we get tangled up with complexity so much that it really makes it hard for us to make progress and deliver value to organizations and to business. Well, in terms of that, I'm going to start by saying when I was a child, I used to tell a lot of scary stories. Now that I'm grown up, I just talk about programming. And that does enough of scare to the world, actually. And when it comes to, if you ask me what do I do for a living, I'm going to say mostly what I do these days is I remove code, then write code. And the reason for that is when I go to organizations, I find that they actually have gotten tangled up with so much complexity. Helping them remove that complexity actually makes more sense than trying to add more to it. And from that point of view, if you really think about it, we are in a world where we all are so excited to be agile. I go to companies, and the very first thing they want to tell me is, Venkat, we want you to know that we are agile. And I always tell them, I'm so glad we got that out of the way. Now let's talk about what you actually do. So the question really is, what does it really mean to be agile? Well, they say that the only constant is change. We constantly have to prepare for change. And especially in our world, every single thing changes around us. It's the business that changes, the technology that changes, the libraries that changes. Everything around us constantly changes. We have to keep up with it. But from the point of view of agility, what does it really mean to be agile? And I'm going to say agility is actually the ability to adapt to change. If you're not able to adapt, and most important keyword here is the word adapt, and if you're not able to adapt to change, what good is it to really be agile? And I'm going to say probably the most unpopular tweet I ever made, and I was very embarrassed about it, because I never thought this tweet would even be read by anybody, but leave alone, this was the tweet that got retweeted the most of all the tweets I've ever made, to the point where I was actually absolutely shocked. And so what I said in this particular tweet is the following. I said I've not set the wedding date. I've set the wedding date. I've not asked her out yet. This is how software projects are managed. If you really think about it, this is so true, unfortunately, about software projects, isn't it? You walk into an organization and they say, we have set the deadline, we have set the scope, we have set everything, and now we're going to be agile. And I always ask them, what is there left to be agile if we've set all those things ahead of time? So the question really to ask is, what does it really mean to be agile? Well, it is to really be able to respond to change. It is to be able to adapt to the change. That becomes absolutely critical. Well, if adapting to change is extremely important, the question is, what can we do to be able to adapt to this change? Well, more important, what are the things that really make it hard for us to adapt to change? And I want to emphasize one word that I care a lot about, and that word is called sustainability. And I'm going to ask the question, are we sustainable? Are we able to maintain a pace of change for a very long time, and can we accommodate this change in a way we can keep moving forward? And so how can we really sustain that kind of agility is the question. There are several things that contribute towards our ability to sustain agility, but one of them that really makes it really hard for us to do is complexity. And the reason I want to talk about complexity is actually very important. And for that reason, I'm going to ask the question, how many of you in this room are programmers, for example? Well, okay, so that's almost everybody here, isn't it? Well, the reason I want to talk about this to programmers is we have the power in our hands to make a change for this. I know we have a lot of difficulties we have to work with. We have to face the business, we have to face the organization, we have to face the management. So there's a lot of things ahead of us, but complexity is one thing we in this room have something to do with. We can actively work towards reducing it, and doing so, we can actually contribute to agility in our organizations. So it turns out complexity makes it really hard to adapt to change. And that's one of the things we have to really ask the question, what makes really hard to change? And one of them is complexity. Complexity makes it really hard to make changes to our software as time goes on. So from that point of view, I'm going to say system design is complicated. And let's not be naive about it. We are working in applications where applications are very complex. You are dealing with the financial application. Well, you're dealing with the tax application. You're dealing with the medical application. You're dealing with so many things, and there is complexity that comes from every single one of them. But there are two kinds of complexities that we have to really keep in mind. One is called the inherent complexity, and the other is called the accidental complexity. Inherent complexity is really part of the problem. It comes from the problem, it comes from the domain. The complexity of the tax law, the complexity of the rules of the banking industry, the government regulations, those are inherent complexity. You cannot walk to your work and say, forget about all of those, we don't care about it. That's an easy way to land in jail, isn't it? So we absolutely have to deal with those complexity. Those are the inherent complexity. Unfortunately, though, most of us in this room, what we deal with every single day is accidental complexity. So what is accidental complexity? Accidental complexity, unfortunately, comes from the solution space. So when you bring up a solution, there's a complexity that comes as part of the solution. And when you have that particular complexity come from the solution, what do you normally do to solve it? You bring more solutions to solve it. And those solutions drag along their own complexity. And now to solve it, you bring more solutions to it, and we get dragged into this vicious cycle and becomes extremely hard for us to deal with this. So if we as developers can recognize accidental complexity and remove it, then we only have to deal with inherent complexity, and that makes our lives a lot easier, makes us more productive as well. So from that point of view, I'm going to say, sadly, we add complexity to what is already complicated. System design is complicated, but we take what is already complicated and pour complexity into it. That's like pouring fuel into fire. And that only makes things even worse, and that becomes really hard to manage. So if we can remove this complexity so that we can deal with the inherent complexity and not deal with the accidental complexity, I think we can be really better. But I'm going to say that we are victims of our own complexity. This is what we do to ourselves. Okay, to be fair, you may argue, Venkat, I didn't do this. I just joined this project, and I see all this code I have to maintain. Well, I tweeted this a few weeks ago. I was at a client site, and I said to myself, and immediately tweeted it, I learned about this. I said, technical debt is the gift you give to the future people that take your project. Because when they come along 2 years from now, what do? Typically, they curse us, isn't it? They curse everybody that's worked on the project before because we've given them that gift of technical debt, and they have to deal with it. So our actions have a very important ramifications to not only what we do today, but for years to come in terms of people who may be maintaining our software projects. We have to be careful about it. So I want to talk about what makes systems really complex. These are simply observations. You are familiar with these quite a bit. You know these, and if you know these, what can you do about it? Hopefully, I'm hoping this talk will motivate you to really rethink about these things, and maybe to go back and influence your own teams to maybe change the practices. Sometimes knowing that things are problematic is not enough. We have to act upon those things, and I'm hoping that this would motivate us to do it. But these really come from real-world problems I've seen. Every single one of them I'm going to show you today are things I've seen on projects and companies struggling to deal with it. So what makes systems really complex, and a software system really complex? Here's my first in the list. The first is too many moving parts. This is one of the things we have to deal with every single day, is applications have way too many moving parts. What happens when you have moving parts in your application? It becomes expensive to keep all of them in line. And there are certain ways we can quickly figure out when we have too many moving parts in it. And this is only getting worse today in the world we live in with microservices, for example. We have more moving parts and not fewer ones for us to deal with. What do we do about it? This reminds me of an experience from a project I was involved in. This particular company started about 15, 20 years ago, and they came to the market for developing certain solutions for various of their clients. But they were very eager to provide a solution that would fit exactly the needs of a particular company. And so they went on to do this. And when they called me to help with them and they started asking me to do code reviews, I'm not kidding with you, I opened the source code and I literally see branches in code that is based on the company for which they deployed the product for. But that they did for a while. And after that, they came to this great idea and they said to themselves, we want to make the application so customized that it would look, the same application would look very different for different customers they deploy in. And where did this lead them to? It led them to the fact where their team of developers would literally spend 4 months configuring their product for them to deploy to one of their customers. So the time for deployment was so huge because they can customize every single thing imaginable to the world. And they did. Of course, you're curious, how did they configure all of this? Well, of course, I think you know the answer for that. Well, talking about distributed systems and moving parts, there's a beautiful quote by Leslie Lamport. It says a distributed system is one in which a failure of a computer you didn't even know existed can render your own computer unusable. So this is so true in terms of how we get into trouble with all these moving parts. But in this particular application, which was absolutely configurable beyond belief, what did they do? Well, they wanted to provide configuration and way too many configurations, unnecessary components, way too many layers of application, all done using XML. So configuration, in XML. And of course, I was, as a programmer, way before XML was introduced. And I remember the time seeing XML being introduced. And honestly, the first, early on, I was excited about it as much as everybody else is. And then as you start using XML, you realize a few things. Configuration in XML is configuration from hell. And it becomes really, really hard to work with. And the more you do it, the more it sucks you in. And sometimes you hear people say, well, XML is not that bad. There's a name for it. It's called the Stockholm Syndrome, right? We are just quite happy with it after a while. And then I came to a realization after a while, and somebody asked me, how do you define XML? And here is my definition of XML. XML is like human. They are very cute when they are small, but get annoying when they become bigger. And this is one of the things we have to deal with almost constantly with XML, is it becomes really, really hard to manage and unbearable as time goes on and becomes really hard to work with. So in this particular project, they had so much XML in there that people would start really configuring it, and they would literally take months to configure this project. And in the meantime, the customers were waiting to deploy the application. And over time, unfortunately, this company really lost its lead because they were no longer agile in terms of keeping up with change and delivering. And that's when they really decided to rethink about what they do. And they went to a complete re-architecture of their product to recover from it. Can be really scary if we're not very careful about how we deal with these things. So what are some of the reasons we should really try to avoid some of these things? Part of the reason is there are signs, early warning signs we can look at. The first is the application is really brittle. It breaks too often. You change something here and something falls apart over here, really hard to maintain it. It's very error prone. It's hard to deploy, hard to test, and hard to reason. In fact, I would challenge one of the things is hard to deploy. If you are having trouble during development, it's an early warning sign that it's going to be really problematic later on as well. But also, one of the things to consider is, a lot of times, people use what are called euphemism. Euphemism is where you say really the bad things in a nice way, so it doesn't feel really bad. So for example, you're working with a team, and they tell you these words. They say, this code is not testable, right? I'm sure we all have heard this particular phrase, isn't it? This code is not testable. Those words in English were said that way, but what they really meant was the following. What they really meant was the design of this code sucks. That's what they really meant. So when people tell you the code is not testable, what they're actually telling you is the design absolutely sucks. So this is one of the reasons why I care a lot about testability. moving parts make testability really hard. And this is an early warning sign. You're having trouble writing automated tests on this code, and you ask the question, why? Well, usually the reason is the design is a reflection of that, or a poor quality design is a reflection of that, and we can take note of it and we can move in a different direction. So that's one thing to consider, is too many moving parts. The next one, I'm still bitter and angry about it. And this one, I'm angry because one of the most valuable things in life is time. And when people waste my time, I get very angry. This particular project, I remember I called it as invisible changes. And the reason I called it invisible changes, this particular team contacted me and said, hey, Venkat, we need help from you. Here is a C++ code. Could you please take the C++ code and rewrite it in modern languages and libraries for really high scale? And when they said this, I shouldn't have said yes, but I really wanted to help them. So I said, sure, why not? Now, just to set the details right, I am not new to C++. I have programmed in C++ in the industry for maybe about 10 years. I've taught courses in C++, I'm going to say for about 15 years. I've kept up with the releases of C++, C++ 11, 14, 17. I know what's going on in the language. So if you ask me if there's one language I probably am the most comfortable with, I would even say to the extent it's probably C++. So I know the language. But when they sent me the source code, I started reading the source code. And I'm reading it and reading it and reading it. And every minute I read the code, I felt like an idiot. And I'm getting angry by the minute. And I got to the desperate measure. I'm like, what is happening here? And I'm not even kidding with you. I'm stepping through the constructor. And I'm looking at the object. It doesn't have a whole lot. And there is one method called get something. You know why I'm angry now? It's called get something. And I step over that method, get something, and the object just pollutes itself with a lot of data. I'm like, damn, how did that happen? Now I'm stepping into the get method. And then from that, another method. This is a rabbit hole I'm going through. And I'm like 7 or 8 levels deep, and I still don't understand what the code is doing. And I was so angry after wasting all this time, I finally emailed them and said, do me a favor, is there a research paper based on which this algorithm was written in C++? And they're like, oh, of course. We thought you would like the code. Like, no. And so they sent me the link to the research paper. I'm not kidding. I threw the code away, read the research paper, wrote the code, sent it to them and say, here you go, and please never come back to me. And that's how angry I was. And then I sat back and thought about why I was so mad at this. And I came to this grim realization. There are 2 kinds of code that frustrate me the most. The first kind of code that frustrates me the most is the one that won't work. And we all have seen this. You're sitting there banging your head, why wouldn't this code work? But even worse, the second code that frustrates me the most is the one that works but shouldn't. And this one is even more annoying, isn't it? And this is painful because you are looking at this code and asking the question, why in the world does this work? And it defies every logic humans can imagine. And at that point, how do you feel when you eventually understand why the code works? You feel totally cheated, isn't it? They pride this out of you, and you're like, you damn programmers, why did you do this? And that's how I felt about this too. And the question here is, you want to remove that element of surprise from the code. Code is not the place to be surprised. This is a wrong place. You want the code to be transparent. You don't want the code to be invisible in its changes, and that is something we have to really try to do. So don't sneak around and start adding state changes. We want to avoid that as much as possible. So too many moving parts, invisible changes. We talked about 2 things. Well, the reason to really avoid these is it becomes a huge time sink. It has an economic impact on what we can do as an organization, as a team, as an individual. And by removing these things, we can save money to our own companies. The next thing I want to talk about is uncontrolled mutability. Now, we all deal with mutability. We all do. We program mutability in Java. We program mutability in other languages. In JavaScript, we program anything we want to. But the point really is we program with mutability. So if I come to you and say, don't do mutability, you're going to look at me and say, like, what is wrong with you? Why would you say that? We do mutability. We are happy with it. So mutability is OK. What about sharing? Well, sharing is a good thing. Remember what mom told us. Share, that's a good thing for you. So sharing is a good thing. Mutability is OK. But shared mutability is devil's work. And the minute you bring shared mutability, everything really fails. If you really think about it, the world we live in is a strange, strange world. Think about this for a minute. Way back in time, we had thread being introduced to us. Clearly, you may argue we don't use thread anymore, we use executor services. But the point still is true, whether you use executor services or thread, what do? You send a runnable to it. Okay, you send a runnable. When you send a runnable to a thread or executor service, what happens? A new thread starts executing while your thread is sitting here and that thread is running. Hey, that's a great idea. I got one thread here, another thread running here. Oh, wait a minute. Let's explore this runnable just a little bit. Remember, you all remember the method of the runnable, isn't it? What is it? It's void run, and that's the signature of the method. Now just stare at that for a minute. What does the method tell you? The method says, I won't take anything from you, and I won't return anything to you. How rude. If you really think about it, this is predictably irrational, isn't it? Because the only way you can use runnable is by putting a shared mutable state. Now, wait a minute. We know shared mutable state is really ugly, and concurrency goes to hell if we do it. And what does runnable say? Let's try that, right? This is predictably irrational if you think about it, right? And I'm like, what were they drinking when they wrote this interface, right? That's what I'm thinking. Because this really takes us in the wrong direction. And what we are trying to avoid is what it tends to promote, really, and that makes life really hard. So we want to really prevent uncontrolled mutability, but as it turns out, mutability needs company. It often hangs around with bugs, and so the more mutability we use in code, the more error-prone our code is, and really becomes hard to maintain it. So one thing we can do to remove complexity in code is to reduce mutability as much as we can, and as a result, it can reduce the complexity of the code as well quite a bit. I'm going to go to the extent of saying that state transition causes brain damage. This becomes really hard for us to work with. In fact, this is something to think about. Programmers often are considered to be antisocial, and I completely disagree. Programmers are not antisocial. We are just social among the right kind of people. And this is one thing that you realize. Only programmers understand this, right? This is one of the things. You always feel at home when among programmers. Why? Because you start a sentence and they complete it for you, isn't it? Because we share the pain, we share the passion, we know how things work. Now, to the point, I'm going to argue, what does it mean to write programs? You are writing code, and in your mind, you are loading all this complexity. And we are a knowledge worker. Your code is in front of you. You're typing the code, but you are in the state. And all this is in your head. You know exactly what object is talking to which other object, where the states are distributed, and everything is in your mind. You are in that complete state of knowing your object structure. And you're about to make this message from one object to the other. At that fateful moment, somebody opens the door and says, have you had lunch? And what do? You just stare at them. You don't say a word. You just stare at them. And they're like, I'm sorry, have you had lunch? And you're like, what? And they're like, you're weird. And they close the door. And they open again and say, are you okay? And you're like, no, I'm not okay. Now you're putting all this back together because this entire model is on the floor. And you see what I'm saying, right? This is how you feel, isn't it? How do you feel when somebody comes to you and says, have you had lunch? You're like, what? Are you an idiot to talk to me right now? Look at all this I'm having in my head. In fact, two people could be programming together and they're chatting and talking. And somebody comes and says, how are you guys doing? And both of them are back on the floor trying to put it together. This is really worse. I'll tell you, hands down, The best money that I ever paid in my life. Oh, it was in a movie. But before that, I've been married for a long time, and I've been very happily married. But part of the reason is, I don't think there's anybody in this world I respect more than my wife. Part of the reason I have the deepest respect for her is, when we got married, she thought she was marrying me. Then she found out she was marrying a programmer. This makes a big difference. And early on in our marriage, there was one day, she said, I want to go shopping. And I told her, hey, I'm finishing this code. I'll be with you in 5 minutes. She picked up the key and left. And then she came back home, and I looked at her and said, you know what, I'm really upset. I told you I'll be with you in 5 minutes, and you just left. And she came to me, put her hands on my shoulder, and said, sweetie, I'm going to tell you this just once, so listen to me carefully, she said. When you say 5 minutes, it's 7 hours in human time. You don't know this. I never thought of it. When she said this, I was like, oh my God, I do this to my boss every day. My boss comes to me and says, how's it going? I'm almost done. 7 weeks later, still working on the code, right? And I did not know this. And she nailed it. She said, 5 minutes in your time is 7 hours in the real world. This is one of the reasons I have the deepest appreciation for her. And over the past few decades now that I've been married, she's been learning the art of programming and are more like what programmers are. She thinks I think she thinks we are a different species. But anyway, the best money I ever paid was for this movie, Social Network. We're sitting there in the movie, and right in one scene, she literally screamed and said, oh my gosh. I'm like, whoa, what just happened? And here's the scene. I'm going to play it. Hopefully the audio is up and running. Let's try this again. So let's go ahead and try this. There we go. So here we go.
I didn't know we had a doorbell.
Andrew, get the door!
No, he's wired in.
He's wired in.
That's gonna cut into your security deposit.
Andrew.
Not now.
Good boy.
I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
That scene right there is when she screamed. And I'm like, what happened? She's like, I know why you are like this. You're wired in. I'm like, take my money. This is good. A week goes by. I was in the kitchen working, when one of my kids came around and said, Dad, I have a question. And my wife is like, don't talk to Dad right now. He's wired in. I'm like, yes. This is the most important thing, and this is the final thing I realized in my life. Happiness is when the world understands programmers. Because now we could just sit alone and code away and not be bothered by these humans. And the point really is that it is so true that we have to focus on what we do. And we concentrate. We think deeply. And a lot of what we do is up here. And that's one of the reasons I'm excited about this profession, is because it's such an intellectual work. You don't have to go elsewhere, but your mind travels distances in terms of how it imagines solutions and we implement it. And that is intense, and that's what we do. And so the concentration is amazing, but anything we can do to reduce that cognitive load just a little bit, just a little effort towards reducing the cognitive load can go a great way. And that is one of the reasons why we want to reduce the complexity for ourselves. The next thing I want to talk about is lack of cohesion. So what is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well, and you want the code to be really cohesive. Like things together and unlike things apart. And that's what cohesion really means. And you want to really focus on making the code cohesive. If we don't make the code cohesive, it really translates to the frequency of change. And if the code is not focused and narrow, and the frequency of change is really high, it becomes expensive to make the change to code. So we want to really reduce the frequency of code. It has a direct economic impact on the code if we can reduce the frequency of change for the code. So in a way, if we can focus on modularity, if we can focus on making every piece of code cohesive, whether it's a line of code, whether it's a few lines of code, whether it's a function, whether it's a class, whether it's a module, whether it's a component or a subsystem or a microservice, if we can make it cohesive, I think we can go a long way so we can focus on reducing complexity. And this is one of the reasons why cohesion can be understood, or the lack of it, by looking at the cyclomatic complexity of code. When you look at the cyclomatic complexity of code, the higher the complexity, the lower the cohesion. It reminds me of an experience I would never forget. This company that I was consulting with, they've been developing this product for 30 years. And it's nerve-wracking for me because when I go there are people who are sitting next to me and they tell me, I wrote the first line of code on this product 30 years ago. Can you imagine sitting next to a person who wrote the first line of code on a product 30 years ago? And the product is making millions of dollars, right, every quarter. And you are looking at this, and these people who wrote the first line of code are still working there, deciding if they would retire first or die first. And they're still there at that code. As I was admiring all this, one of the developers came to me and said, let me show you something, Venkat. And he takes me to his desk. And they have one version control with 30 years of code in it. And he drags the timeline to 15 years ago and drops it and shows me a function. That function, 15 years ago, the day this function was born, I can see its entire naked body in front of me. Beautiful function. Very little, small little fingers. Only 2 parameters to it. I can read it and understand it entirely. And I was like, wow. And he showed me the cyclomatic complexity of the code. Thomas McKay's cyclomatic complexity says 10 is high. And the value for this was a 5. And I'm like, wow, what a small function. Complexity is 5. This is amazing. As I was saying it, he drags the timeline in front. And in front of my eyes, that beautiful little code turned into a monster. Don't even ask me how many arguments, parameters this function took. I don't think I want to say that ever. And I could not see the bottom of this function, this huge function. And I'm looking at this function, and he says, now look at the cyclomatic complexity. A value of 864. And then he said, that's what we do to code in this company. I'm like, where's the nearest exit? I want to leave. And if you never refactor the code and keep on writing code to it, imagine how complex it can become over time. Really hard to work with. Cohesion is extremely important. The next thing I want to talk about here is excessive dependencies. We all deal with it every single day. Who enjoys working with dependencies? Raise your hand. Not a single person. Okay, one person trying to raise the hand. We'll talk to you after this session. Well, everybody hates it, isn't it? Why do we, dependencies are required, right? You cannot live without them. You cannot live with them also. Dependencies are very important. But when it comes to dependencies, what happens? I thought about my own career. I've been programming for 35 years. And I looked at the career I've had and I said, wow, what have I done? And I finally realized I can summarize my career in this tweet. And that is, I've had one hell of a programming career. From DLL hell to jar hell to assembly hell down to NPM hell. What's the next? And we already know what that is in Java. It's called module hell. But the point really is, this is one heck of a career when you can deal with going from one hell to another to another. The latest one is my favorite. I was on the flight the other day, and everything was going well. The captain came on and said, folks, we have a smooth flight. I'm turning off the seatbelt sign. You want to move around? Please do. And I shouldn't have done this. I opened the laptop, and the only thing I did was I typed npm install. Immediately turbulence. I'm like, sorry, didn't mean to do it. And the seatbelt sign comes on, and the rest of the flight is horrible. I never do npm install on flights anymore. But the point really is, npm is a great example because the minute you type npm install, it will download the internet with vengeance. And then it will go look for other things to download. And of course, I was mentioning this to I was working on a project. This was a JavaScript project. And this developer said to me, oh, we quit running automated tests on this project. I said, oh my gosh, why did you stop running automated tests? Oh, some of the libraries, we upgraded them, the packages, and the tests don't work anymore. I'm like, really? How many packages are you using? He said, oh, about 150 of them. I said, on this small project, 150 of them. He's like, you don't believe it? And he opens the dependency file and shows it to me. And then I said, why are you using 150 libraries on this project? He shrugged and said, because we found them. And that is such a wonderful answer, isn't it? For I love this kind of honesty. We found them. This is so true, isn't it? You are out to lunch with your team. As you're having your meal with your team, in the next table, somebody is talking about this XYZ package in JavaScript. And you look at your team and say, have you heard about it? And everybody is so hurtful. No. And 30 minutes after you come back from lunch, it's in production already, right? This is how we do things on projects in JavaScript, right? Because we have to use everything. Why leave a few things alone? And I was mentioning this to a developer, and he told me, oh, we don't have any problem dealing with dependencies. I'm like, really? What kind of project are you working on? Oh, we work on Java project, he said. Really? How come you don't have problems with dependency when you work on Java projects? He said, because we use Maven. I had to deliver the bad news to him. Nobody uses Maven. Maven uses you. So, what I mean here is that dependency uses you through Maven. That's what it is. You get dragged in, you get beaten down, and you don't even remember what you're doing anymore. And this is one of the things you have to deal with constantly. The complexity just kills us. The dependencies just hurt us. It becomes incredibly difficult for us to work with. So the point really is, if we can take the effort so it is very easy to bring in a dependency. Very difficult to remove it. If the cost of adding a dependency is $1, the cost of removing it is several $100s. So we have to be really, really careful bringing in dependencies. Otherwise, we're going to get hurt really quickly. So dependencies are really hard to maintain, become obsolete quickly, and become incompatible. The teams that are the slowest in moving forward are the teams with a lot of dependencies. The teams that are more agile have fewer dependencies. The next thing I want to talk about here is technology infatuation. And this is something that scares me. Technology infatuation is where developers are so eager to use everything new and shiny. And don't get me wrong, we should learn constantly. But I always want to keep learning separate from my production code. I will spend my time learning new languages, new technologies, new tools, new libraries, new framework, but all in a side project. Once I learn about them, I'll have the wisdom of not using it on a real project until a real project clearly demonstrates a need for something. And if we are not paying attention to it, we could quickly get dragged into it and make it really hard to work with. And what happens if we do? We have to ask the question, is this the right technology for us to use? And we have to be very careful about it. And if we are not asking that question, things can become really hard. One criteria to consider is called reversibility. So what is reversibility? Reversibility is our ability to back out of design decisions. You make a decision and you say, that's not the smartest decision I made, I want to change it. And you want to be able to change it. If you're able to change it, it's reversible. If you're not able to change it, it's irreversible. You have to be very careful. One of the questions I always ask my design team and architects is, how reversible is this decision? If it's reversible, go for it. If it's not reversible, take some more time to evaluate it. Don't be in a rush to take it. So one of the things to consider is libraries versus frameworks. Now, I'm going to say libraries are a bit easier to work with than frameworks from the reversibility point of view. Now, the use of a library is easier to reverse than the use of framework. But I do want to emphasize one thing. When I say it's easier, I use a term called surface area. Suppose this is a library that I want to use. And suppose my code is using the library like this. Notice the surface area of my dependency is pretty huge. If I want to change this library, it's really hard because I got a bigger surface area. On the other hand, if I have a smaller surface area on this library, when I want to replace it, it's easier for me to replace it. So when it comes to designing with libraries, you want to minimize your surface area and not really make it bigger. And if you are able to manage your design that way, it becomes easier. Unfortunately, you can design a library to minimize the surface area, but a framework is a complete opposite. You don't use a framework, the framework grows around you. The framework, by its nature, has a bigger surface area around your code. It's very difficult to remove it. Here's a silly analogy to think about. I'm going to say the way to think about it is using a library is like dating. Using a framework is like entering into a marriage. Don't take this too lightly. You can date and you case, this didn't work out between us, we'll just be friends. That's okay. But entering into a marriage is more expensive. You want to make sure you really are committed to doing this. Otherwise, it can be really, really hard. So that's one of the reasons I'm very reluctant in using frameworks compared to libraries. I usually spend more time evaluating it before I jump into it, and that can be really expensive over time. So having said that, the question to ask is, what about technologies? I'm not here to tell you that the past was better than present. But there is one difference, though. When I was young, when we didn't have the internet, this is always a great discussion to have with my children. They look at me and say, what do you mean you didn't have internet? What do you mean there was no Google when we were young? And this is always weird, right? Because people don't understand there was a time in the world when we didn't have internet and Google. But in that time, if I want to use something, first I have to come to know about a product. And once I get to know about a product, you ask for a permission to use it. You then have to send a purchase order. You have to wait for approval. And then eventually, one day, you will get this tape drive. And this is how I spent my youth. I will go to the tape drive machine and put this tape and start installing the product. When there's a tape drive between you and the product you want to use, you don't use too many products. Today, you just click a button and you can download it right away. And within seconds, we can integrate so many things into our products. And all of a sudden, we have enormous dependency compared to what we once had. And that can be really, really problematic. So what does this lead to? I was talking to the developer the other day, and he said, we have committed to using this particular tool. And I said to him, well, you don't need it, do you? He said, don't come talk to our boss. We convinced the boss we need it. There's a name for it. It's called resume-driven development. We use products just to put them on the resume, and that can be really dangerous as well. The last thing I want to talk about here is a tale of infatuation. And this is a very sad story. This was a time I was working on a project. When this particular project, we were hiring people. We were desperate to really keep moving. It was a 6-month schedule for this project, and we were very eager to work on it. We were interviewing people. There was one person we interviewed, loved this person, amazingly smart. And my boss came to me and said, what do you think of this guy? Oh, don't waste your time talking to me. Go hire him. Yeah. What do you think of the framework he's developing? Best framework I've ever seen. Don't waste your time. Go hire him. What do you think of us using the framework? I said, no. Sit down. Don't go there. Hire the person for the work. Don't talk about the framework. Oh, but what do you think of this persistent messaging framework? I said, you never used those words in a sentence before. Don't do this. A week goes by. He comes to my desk, sits on my desk, and says, Venkat, I got a great news for you. I said, what is it? Well, we have hired this guy, and he's accepted to come and work with us. I said, yes, I cannot be happier. We're going to have a lot of fun. I'm so thirsty to learn from him. One of the smartest guys I've ever seen. I'm looking forward to it. Oh, as part of the hiring contract, we have agreed to use this framework. I said, oh, no, you got to be kidding. No, it's true. Well, I quit then. He said, oh, you're so predictable. I already told my boss you will quit when I say this to you. I said, I'm thankful at least I'm predictable to you. I'm out of here. I packed my stuff, and I said, so how long are you guys going to get to finish this? Oh, we'll be done in 6 months. I said, good luck with it. I don't want to be the person telling you this is a bad idea every day. Go for it. If there's any other project, call me. I'll come and work with you. This is one of the very few days I actually showed up home before or on time. My wife is like, hey, you're home already. Yeah, I quit. And like, what does that mean you quit? Like I don't have a job. Well, in that case, I got some dishes for you in the kitchen. That's how things rolled. And 18 months later, 1.5 years later, I get the call. Hello, this is Venkat. Hey, go ahead and say it. Like, say what? I told you so. I'm like, oh, what happened? Well, we've been programming for 18 months, and we're still working on it, and we're not done yet. Why are we not done? Because we've been writing more code towards the framework. And that's when I realized they have been writing more code to a framework which they didn't need in the first place. I said, I'm really sorry. What do you want me to do? Oh, we want you to come and work with us. I'm like, no, there's a reason I ran away. I'm not coming. 6 months went by, and I get the call again. And this time he said, okay, I know you don't want to come and work with us. Just one day. We'll pay you for the day. Come, take a look at the product, write a report, you're done. I'm like, you guys are done with the product 2 years later. Oh, yeah. Okay, great. I'll come and look at it. I go there, and there's a computer sitting with the product running on it. And I enter a little example. I click the button. 25 seconds later, a screen pops up. I'm like, whoa, that took 25 seconds. He's like, uh-huh. And I profiled it. That one click created 1,863 objects. I said, did you see that? He said, uh-huh, it's object-oriented. And then I said, database. He said, this is twice as fast as what you will find. Machine speed, oh, much faster than what you'll find in production. And then I asked him, where's everybody? And he said, the entire team has been fired because the product was so poor in performance, they couldn't tolerate it. And then I asked him, can you really tell me why you called me here? Because I have a feeling you didn't call me to write a report. He said, fix it. I'm like, no, I'm a mortal human being. I can't do it for you. And this really hurts me because we worked so hard on the product, and yet we failed so badly. So don't build what you can download, but don't download what you really do not need. And this is something we need to be very careful about, because if we're not really careful in bringing in the dependencies, we could be really hurting for a long time. So given this, we can minimize all of this a great deal in terms of how we can reduce complexity of our applications and deal with it. So what I want to complete this with is we talked about quite a few things about reducing moving parts. We talked about invisible changes. We talked about mutability and cohesion, and also dealing properly with dependencies. Well, one of the things I would emphasize is we should learn to deal with complexity and have the wisdom to minimize it. And the reason I emphasize this is we in this room have the greatest ability to do that because we are the technical people. This is not something a non-technical person can deal with because we understand what we are dealing with every day. And we have the power to manage these and reduce this. And this is the reason why we should take responsibility professionally for this. Maintainable code, I'm going to argue, is the gift we give ourselves for the future. And we should put every effort we can to make the application more maintainable. It has an economic impact, and it's got reasons to make the product better. And that's one way to stay agile as well. Hope that was useful. Thank you.